All right, so now that we actually have a potentially working, like at least a valid schematic, and the PCB laid out correctly for that, with some optimizations, the next part is to start sorting out all the silkscreen and then validate that the physical attributes of the PCB will pass at the manufacturer. So let's start with that silkscreen. So here we go. And I also just noticed, looking at this, that there's like a wire hanging in the middle where it actually just doesn't need to be. So let's just nuke that. Alrighty. So when we want to look at the silkscreen layout, what's more useful is to just get rid of, let's not worry about any of the copper, right? So firstly, I'm going to focus on text. I think text mainly, and go to the layers, and let's just choose front assembly view. And that's already looking better. I'm going to eliminate the courtyard and the front fabrication data. And now we're kind of looking just at, this yellow layer is the front silk screen. So immediately we can see a couple of things here, like, this designator is off the board and this one is clashing over here. This one, maybe just want to move these. Actually, we could probably do it with all of them at once. Potentially even all the others. And let's just focus on one of them and move it just so that it's a bit more obvious which jack we're talking about. Okay, that's okay. It's basically the edge of the board is the silk screen for the LED is just going to get clipped by the edge of the board, not a transmesh. I'll just remove all the components here and we'll see exactly that, right? And this is actually another way. So if I press Z in this view and maybe just make this longer, maybe we just pull this to the side over here. And then we can see it as we're working. So, and let me just take perspective view off. All right, so now we can really see where the silk screen is a problem as we go. So D3, let's maybe make that, rotate it like this. Bring FB2 over here. If we hover over, then we can see the changes happen. That one's going to get clipped by that wire. That wire's clipping there, but I don't really care. It's just that over there. All right, let's just move that. Move this under here, perhaps like so. C4. And also it's just to make, like if this one was over here, it would be a little ambiguous which capacitor does it relate to when we're looking at the board. So I'm just going to make sure that all of these things are obvious. The jacks we sorted out. Yeah, and that's the front silk screen pretty much sorted out. I think it's clear what belongs to what and that we can read them perfect. All right. So on this view, I'm going to press, I think, Shift-C. Yeah, like a capital Z. And then we can see the back. And over here, I'm going to switch to the back assembly view. And again, just get rid of the back fabrication layers and the back courtyard, just so that it's cleaned up a bit. And then we can start seeing the issues. So U1, R1, R2, R5, all looking good. R3, R4. I think that's nice and clear. U2. Just make that a little more obvious. Part of me wants to move it here close to pin 1. That little triangle is pin 1. Just so that, yeah, because when you're actually looking at this in real life, it's probably more like that. And seeing that little triangle is often not that obvious. So I've done it like that. C7, R10 is getting clipped by that via, so maybe we just do something like that, or even like that. That's cool. Yeah, J9, whatever. R6, R7, oops, R8, R9. Could it have been any simpler? Great. So we're now happy with the silk screen for everything. Maybe I want to see about doing the same thing for U1. Yes, it's possible. And I think it's reasonably clear based on the pattern of R1, R2, R3, R4 that U1 is referring to this. So I just moved it close to that pin 1 marker. All right. Wow, that was easy. So something else we could do is add a text component, maybe use the knockout, put it in bold, maybe make this the width and height a little bigger, and just say infinity modular 20, where are we, 2025. Yeah. And let's do it like this and call this buffered malt version 1.0. Let's try like that. Okay, so then we've got some text that's actually a lot bigger than I thought it would be. Let's keep it at 1.1, so it should be half the size roughly. And maybe change the font, something a little more sexy. Even Arial would be more sexy than that. I don't know. It really doesn't matter. Let's just stick with Arial for now. Maybe Arial Black. Let's see how, yeah. Okay. And then just try find a place for it. And this really doesn't matter if it gets clipped by little vias or something. But at least now we've got a like, what is this module? That's kind of useful. Maybe we move it over here. Cool. So now we can see that on the back. Maybe we want to make a copy of this, paste it, and flip it to the front. It disappeared when I flipped it because we're only looking at the back layers. So let me look at the front assembly view. Get rid of the front fab and the front courtyard. And find a place for this. Maybe it even goes nicely over there. Let's go back. Yeah, so there we've got, where is that via? Yeah, it's actually not showing here, that via. But anyway, so looks good enough. So we've got some kind of a label. What is this module? and so on. So you can add whatever other things you want. I mean, sometimes I go as far as actually putting the values of things on, which we could grab from the fab. So here we've got a fab layer, bit of text, I guess, which we could copy onto the front silk screen. Let's just remove the fab again. And perhaps one makes that 0.7. Let's try like that. So, so one could actually go as far as putting all the values on. Sometimes it's helpful, especially with SMD stuff, when you're really looking in a microscopic view, when you're kind of soldering stuff on, especially for resistors and capacitors and things, that could be helpful. But I'm not that fussed, because, of course, the other thing that you can do is the whole idea with this, with a assembly view, is that you get all those values, and you could print it out. So if I actually laid this out, all of these values, in fact, if we get rid of the mask and the courtyards and everything else, then we could lay this out. You see the C3 is inside that thing. We could then make this like 0.7 and fit it there. In fact, if I get rid of the silk screen, it becomes even clearer. So I could lay out all of the stuff, and then you'd have something that you can print out. While you're building it. Oopsie, I actually moved that to the wrong one. So you could print this out and then use it, right? So I'm not going to go to all the detail, because actually what I tend to do when I'm building the thing is to generate an HTML BOM file, an interactive BOM. Right, so you can kind of definitely get it from here. External plugin tools, external plugins, and generate interactive BOM. You may have to actually install that plugin. So if I generate that BOM, then I get this this view, and that's kind of useful. So if I'm busy working with the front, I can see which component values are which and tell it which ones I've placed and so on. So this is kind of useful, right? And if I switch to the back, I get the values on the back. So I find that I like working with this when I'm soldering. Okay, close that. So yes, so what we've now got, if I just show all layers again, and maybe get rid of a bunch of the noise. So now what we've got is a board with everything laid out neatly, including the silk screen. But there might still be some little issues that we introduced while we were doing this layout, especially with as it relates to the copper and the distances of tracks from one another. Sometimes, despite the fact that there is a routing engine, sometimes it's not quite perfect. All right, so what I'm going to do is what we call the DRC checker, the design rules checker. So it's going to check against a whole set of design rules for any errors in the design. And I expect to see a list here. So I'm going to run the DRC, and there are 17 errors. Oh, it's not too bad. And most of these are the jacks. The courtyards are overlapping, and we know they are, and it's okay because we've verified that on the, there is physical space for those jacks to fit, and it's okay in this sense. So, something that I don't have turned on are the DRC warnings and errors. So we can see them. We can see all these errors over here. So let's start off with those jacks. Like as we click on them, it takes us to where the problems are, and we can see this little arrow saying these two are overlapping, but I don't care. So I'm just going to exclude this violation. And the next one is this one here. I don't care. And the next one is also jacks overlapping. Don't care. Don't care. More jacks. More jacks. Exclude violation. Great. But now we come to something that's possibly a little more valuable. So we can see here it's saying that this chip, oopsie, is too close to the edge of the board by 0.135 millimeters. So it's very slightly too close. So in fact, if I press D, and you can already see it's clashing with the top there. So there it's not clashing anymore, but I can't move it. Did it move? No. But I can't move it closer because this track's then in the way. So what I'm going to do is just get rid of that trace for now. I'm going to select the footprint and press D again to kind of grab it and move it until that little indicator at the top. Oh, okay. Subtle. Let's do that one more time until that little indicator that it's clashing at the top goes away. D, and just use the down arrow to shift it. Okay. Oh, it's still clashing with that corner. Let's just see in the top right there. At some point, it's going to start clashing with something else. Okay. So that's good. Now, of course, we've moved it. So a lot of those errors should disappear. These ones are about that LED. Okay. So I'm just going to close that for now. Problem is here now, there might be copper traces that are a little bit, since we moved the thing, like over here, for example, this, in fact, that's clashing, that capacitor on the front, that guy is also clashing with the board edge. So I'm just going to do the same to it. Hit enter, and then just verify that the traces, just going to redraw it. Redraw the trace. We also removed a trace over there, I think. So you can see these two DRC errors, I think. Yeah, you can select and double click it and it takes you there. So that was saying that those guys were clashing, but we've just moved that. So let's run it again. Nice. And those errors are gone. I would also just like to double check all of the traces over here. So I'm going to dim this. regenerate the, okay. Yeah. Let me just do that a little bit neater. So on the back copper, those all look fine. I mean, could say move that into the center. Just a visual thing, really, nothing to worry about otherwise. Okay, so the back copper looks fine around the chip there. I guess technically we could move that out. You know what? These files are so big, I'm not... okay. I'd rather... Okay, but that's fine. Okay. That one's causing that little mini angle in there. I don't like those. I think generally speaking, this stuff's okay. In fact, what I could do here, let's do something like that. But it won't go any further to the edge just because of that. But it's all right. It's not the end of the world. Okay, so I think I'm pretty happy with the back copper. So by the way, the little yellow arrows are the DRC checkers warnings, and those are errors. So let's have a look at the front copper again. Nice and tight. Okay, yeah, I'm happy that that we didn't mess up any of the actual connections. Also, 0 are unrooted, and the DRC error would pick up if we had accidentally, for example, bridged the 12 minus 12 and 12 or something by moving that component. Okay, so let's run the DRC again. And here we have that arc cut it's saying is too close to the LED. Now, quite frankly, it's not that much of an issue, but we've got a little bit of space, so I wouldn't mind moving it just a little bit to the right, and it looks like we could do the same for this one. So if and it's also got a little unhappy sign there. Of course, as I move this, it's going to change the available space for tracks and all that kind of stuff. So right now what I'm going to do is I'm going to delete those traces around it, because otherwise they are going to block us moving things. Okay. So let's just check the other one. Yeah, it's also, no, that should be all right. So if I select both of those, and I just press D to drag, you can see that on the left, this kind of green highlighted thing is a problem. I did a major jump there, just not happy with that. D. Okay. Oh, you know, why? I just use this one. Does it still jump like that? Of course it doesn't. So, okay. Thing is, I want them. It's fine. I'll move this one and then I'll align the other one. Okay. So that one should no longer be complaining. That's probably moaning about the silk screen, and we don't care about that. So for this other one, instead of drag, you see the benefit of dragging it, you see it actually holds whatever's connected to it remains connected to it, as opposed to moving it, which disconnects it, right? So I prefer dragging it, but these are very simple components. There's nothing much connected here. So I'll just disconnect that stuff. And yeah, I should be able to drag it. The only thing it might collide with is that line there or that pad there. But let's see. So instead of dragging it, I'm going to align it. Right click, align horizontal center. There. So it's moved. But we'll for sure want to reconnect everything. So, and sadly that can't get round there, but that's all right. So we'll want to reconnect that. This would have been, it'll have to come around this way because otherwise we will have a problem because we can't get this one through. So I'm going to connect that one up. And we can use that extra piece of line. And now, of course, we've got this little island. Again, not the end of the world. Perhaps what I could even do is shift this all. Let me try to drag it. Drag that. Drag that. And then drag that. See if we get enough. Nope. Drag that some more. Let's just see if we're able to get to a point where the outside fills. Fix this up. There we go. Okay, so we have the LEDs. So let's again run the DRC check. Look at that, no errors, but there are 9 warnings. So we go through those. So silk screen clipped by board edge. Well, it's that one, right? And we know what that's about and we don't care. So I'm going to exclude this. Then it's saying, okay, wherever the Jack's silk screen is clipping the edge, I also don't care. So J8, I'm going to exclude. And then Jack 8 again. It's just this is going off, just off the edge. So I really don't care. Exclude. All right, then it's saying, wonderful. So this doesn't match the footprint. It's saying doesn't match the copy in the library for U2 and U1 and diode 4, diode 3. Okay, so I'm just going to, well, let's have a look at the last one here. It's saying that U1 is getting clipped. Just the text field here is getting clipped by that input. So let's have a look-see, because I don't, oh, right, of course we moved we moved this down. So quite frankly, what we could do, let's just go back to the front. Let's go like a front assembly view and then all layers view again. Okay. And then just, we don't want all layers, we want front assembly view. No, we want back assembly view. Right. And there's the problem there, right? So let's just move this. And quite frankly, we can just put it inside. You know, it'll be covered once we actually add the chip like this. Now we can no longer see it. I don't know. I guess maybe we can just move it here. We just got to be super careful that we make note of the pin 1 when we're actually soldering. But at least both of these are facing the same direction, so it's maybe not super important. So let's run that DRC check again. Okay, one less problem, and now it's all just footprint problems. So to be honest, I'm not even sure why that's the case, but let's have a look. So if I say update this footprint, the selected footprint, let's just say update, it says it's okay. Let's run the rules checker again. Yep, that did seem to fix it. So let's do the same for this one. Oopsie. Update footprint. Update. And then for both those diodes, there's one. There's one. Update footprint. Update. And the other one, update footprint. I mean, one can update all footprints in one shot as well. Let's see. No warnings, no errors. So it is very likely. Why do we still have... seems that they're kind of there, but not. Let me just... Fascinating. If I hide warnings and errors... Okay, I think that's just a defect. Let's just say all layers again. They seem to have vanished. So good. One last time for good measure. Oh, it's the exclusions. I think that's what it is. So it's all of those ones that I excluded, right? There it is. DRC exclusions, warnings. So I won't show the exclusions. Okay, so now, remember we also moved stuff around. So I'm just going to validate that the Silkscreen, just get rid of all the components. So I'm just going to make sure that everywhere that R10 is not that wonderful. This is on the back. So is it? Back assembly view. R10, yeah, it's getting clipped by that via. I could just put it there. Yeah, good enough. Just check the other ones. Everything else seems to be fine. And then if I do the front again, just for the front assembly view, and I shift this over to the front, does anything look bad? No, I'm happy. Okay. So we now have a DRC validated board. I'm just going to show everything again, all layers. Right. So when you show it to someone, always show them this view because it looks far more impressive. Right. But yeah, so that's kind of cool. So where we're at now is we validated the board, and now if we wanted to, if we're happy that this is what we want to get from the manufacturer, then we can export this. And in order to do this, just going to save again, always save regularly. In order to do this, we can go to File, Fabrication Outputs, Gerbers. So I'm going to do that because the Gerber files, or the Gerber project and its various file layer files, is what the manufacturers then use to set up their production line. So I find generally that it's selected all the right things. For sure, we want an edge cuts layer. We want the back and front solder mask. We want the back and front and back silk screen paste, and definitely we want the copper. Okay. Everything else here, I also just leave at the defaults. And yeah, I guess if you're in the States, I don't know. I don't know if you're ordering boards from China. I'm not sure if they prefer millimeters or inches. I don't think, or mils. I don't think it really matters. But I've just leave it at the default. All right, and then also part of this is we actually want to generate drill files because all of the holes actually need to be drilled, right? So I'm going to say, let's first change the output directory. And for this, I could just select over here and make a new folder. And I'll just call it CAD, or CAM, rather. Open that. And yes, I want to use it as a relative path because if I ever move the root of this file directory structure to somewhere else, then this will still work. So, all right, generate the drill files. Again, I leave everything. I leave everything as is and just hit generate. Nice, done. Didn't see any errors. Close, and then hit plot. Again, done. So, and what this is doing literally is generating a graphics file or a specific Gerber file for each of these layers. Okay. No warnings, no problems. And, something that wasn't here. I want to subtract the solder mask from the silk screen. That's actually an important one because we don't want to be drawing, like if there is anything that's clashing with a pad, I don't want to be painting silk screen over it. So that's what that's about. So I'm just going to check that. I'm going to just regenerate everything, plot again, and close. Okay, so now what we should have is in our project, we've got a CAM folder. And in there, we can see, here are all those different layers, right? Along with a job file, a Gerber job file. So I could load this, for example, in the Gerber viewer. And here we have it. So this is what the manufacturer gets. It's just like a simplified version. And, what you could do is just look at things one by one. So you could say, that's just the edge cuts. And there's the front paste. Let's look at the front layers. Here's the front mask. Here's the front copper. Kind of cool. And the rest is the back. So those would be the front layers, and the back layers would be these ones. Okay, so yeah, so then we can get a sense of what this actually would look like for those people, the manufacturers. But I'm not too worried about that. So what I'd usually do then is I would just go to this cam folder, or maybe even actually to the project root folder. And on Mac, it's pretty easy. I could just right click on this folder, compress cam, and I get a cam.zip, and I could just call this I am buffered melts v1 v1.0, and maybe just say Gerbers. And this file is now literally ready to be uploaded to your manufacturer of choice. And yeah, and then you can get to choose, what color you want the solder mask. So, if, you could say, listen, I want a black board, and then it would look something like this, right? You can choose. I find that for surface mount stuff, I like a nice bright color so that I can easily spot components. I mean, if you're working with a black PCB and you've got these tiny little black diodes and things, you can lose stuff very quickly. So yeah, I prefer red for SMD. Black's fine, and white even for through hole. But yeah, high contrast is good for SMD. All right, so that kind of gets us all the way to manufacture. I mean, if you're wanting to look at how to actually select and choose all the right options on a particular manufacturer's site, we can do that. But I'm not sponsored by any of those kind of people, and frankly, I think the choice is yours as to who you want to work with, what makes sense for you. Awesome. So we've done all of that. I think what I'll do is call it there, and in the next episode we'll look at now how do we get a faceplate designed that we could also potentially send to the PCB manufacturer. I find it's a quick and easy way, and with pretty good quality as well, to just get a PCB faceplate. And again, you can choose the color and so on. Obviously, the writing is going to be monotone on it, but that's still pretty cool. So yeah, we'll do that in the next episode. Thanks for watching. Good luck.